All right, here we go. So, ladies and gentlemen, today we're going to do chapter 2.1, day 1, functions. We have 2 goals for today. Goal number 1, it says that we are going to determine whether a relation represents a function. And then goal number 2, we're going to find the value and domain of a function. So that's our 2 goals for today. Goal number 3 we will talk about in the second day of notes, okay? So let's get started, okay? Function. You have talked about functions in Algebra 2, so this should be somewhat review. When we're talking about functions, we're talking about domain and range. We are talking about x and y. Okay, now alphabetically, x comes before y in the alphabet just like D comes before R. So that's a good way to remember. Domain matches up with X, and range matches up with Y. Alphabetically, it makes sense. X, then Y. Alphabetically, D, then R. Okay? Now, instead of Y, you're going to start seeing function notation, which is f of x. So you have to know that Y and f of x are the same thing. Okay? This just is the function in terms of x. Okay? So again, y is the same thing as f of x. Now, we say that x maps to y, and we can write that as a coordinate point, x comma y. Or maybe you prefer function notation, it would be x comma f of x. Some other words that we use when we're talking about functions, we talk about input and output. When you have a function, a lot of times we take the x is a value and we plug that in, and then we get something back out. So if I had like y equals 2x plus 3, we would plug in a number, and then we would get something back out for y. Okay? So domain, range, x, y, input, output. Also, your textbook uses the independent variable versus the dependent variable. Okay, x can be anything you want. You can choose to plug in any number for x, but y is dependent on what you choose for x. Okay, so it's like mom and dad. Mom and dads are independent. They can do anything they want to do, and you guys are dependent on them. So it's all about what the independent variable does, or the independent. All right, so before we dive into functions, we have to understand what a relation is. It says here a relation is a correspondence between 2 sets. Okay, here I have one set, are these people, and I have this other set, and that's their birthdays. So I have people and I have their birthdays. Okay, now if I have a correspondence between 2 sets, that means every x has a y. Or every person has a birthday. Okay, so when I take a look, does every person over here have a birthday over here? What do you guys say? Tap your head if you think the answer is yes, this is a relation. Tap your head. Tap your head. Is this a relation? Does everybody have a birthday? Tap. No taps? Can you guys hear me? Can I get a thumbs up? Okay, so is this a relation? Yes or no? What do you guys think? Yes, it is a relation, okay? Every person over here has a birthday over here. Now, if we want to, we could write these as ordered pairs, okay? So, for example, when is Chris's birthday? Chris's birthday is when? What do you say? John, Trey, Logan, when is Chris's birthday? December 16th. Perfect. Next, I have Indiana. Indiana, May 31st. You guys okay with that? I'm going to write Indy for short. That's May 31st. Then we kind of go through the line. Courtney, when's Courtney's birthday? What do you guys got? December 29th. And we kind of go through the line. Peyton's birthday is February 8th. And then Lucas, his birthday looks like September 1st. Okay. Now, these people are people in my household. Okay. So Lucas is my middle child. He's born on September 1st. I put this stuff here so I don't forget. Okay. Because as we get older, we forget things. Peyton's birthday is February 8th. My wife, I can't forget my wife's birthday. Courtney, her birthday is December 29th. My dog, Indiana Jones, Gotch, was born May 31st. God rest his soul. He passed away just recently. Don't cry though, girls. It's okay. And last but not least, my birthday is December 16th. December 16th. So if you're interested, you guys should know by now I like Star Wars. I like the Bears. My favorite color is blue. So if you guys are looking to celebrate my birthday, there you go. Kidding, I'm kidding. You don't have to get me anything. But I hope we're in class that day and we can see your nice smiling faces and we can celebrate my birthday. So ladies and gentlemen, this is how to take these sets and write them as ordered pairs. Super easy stuff, okay? Now that we understand what a relation looks like, whether it's, I call these birthday balloons or you have ordered pairs, well now let's take a look at what a function is. So a function is a relation, okay? So a function is a relation where every x has only one y value. So it only has one. Okay, for our example, every person has only one B-day, birthday. So normally people only have one birthday. It's crazy to think that somebody would have two. That's just not normal. Okay, so we're going to go through and write some people's birthdays down. Okay, so Don, when's your birthday? Donovan. Nice and loud so we all can hear you. September 16th. September 16th. Is anybody else born on September 16th? Nobody else. All right, next. Lydia, when's your birthday, girl? October 10th. Is anybody else born on October 10th? Nobody else. All right, my name is Nick. When's your birthday, bud? July. That's a pretty popular birthday. Does anybody else have July 31st as their birthday? Anybody else? Anybody at all? I do. Who's that? Sarah. Sarah? Yeah, I have July 31st also is my birthday. Sarah also has the same birthday as Nick. Isn't that crazy? Sarah has the birthday on July 31st. Is that okay? Is that a normal thing to have two people to have the same birthday? I mean, if you look at, you guys are on, Chat Snap and Bookface or whatever, and you got to wish people happy birthday, right? Don't you have to sometimes wish multiple people happy birthday? What's that? No? So it's okay for these two guys, I should say Nick and Sarah as a girl, it's okay for Nick and Sarah to have the same birthday. Totally fine. This is a function. Totally fine. No problem. Okay? All right, let's walk through this one now. Emily, when's your birthday? Let's do another one. Emily L., when's your birthday? Nice and loud. March 4th. Den, when's your birthday? June 21st. Whoa. June 21st. Nice. And let's go with Tori. Tori, when's your birthday? I
have 2 birthdays.
You do?
I do.
Get out of here. When's your... That's crazy. When are your 2 birthdays?
December 23rd and March 4th.
And March 4th. That's crazy.
I know.
You cannot have 2 birthdays. You can't do that. Tori. Girl, you can't have 2 birthdays. So Tori, silly Tori, she says she has 2 birthdays. That means this is not possible. This is not a function. You can't have 2 birthdays, Tori. Oh, that silly gal. All right, so do you guys see the difference? These x's are going to y's. It's okay that these 2 are going to the same y. That's normal. But Tori, this x is going to 2 different y's, has 2 different birthdays. You can't do that. Okay? So this is one way the textbook goes through, and they use these, I call them birthday balloons that might be boxes or squares or whatever, and they show the images over. They could also show you a list or a set of ordered pairs. Okay? So if you want, you can go through and make these birthday balloons. Okay? So again, we have x's and y's. So I'll just kind of walk you through this real quick. And then you guys can decide. Nice job, Tori. So x and y, remember domain range. 2 goes to 6. So you write it 1 time. Okay? The next point, I have -3, 6. Now I have -3. Don't write a number twice. Once you write it in one of the bubbles, you don't write it again. So -3 goes to the same 6. Don't write another 6. Okay? Now, before we go any farther, is it okay that 2 goes to 6 and -3 goes to 6? It is okay for these 2 people to have the birthday on December 6th. Is that normal? What do you guys say? Devin's giving double thumbs up. That is normal. So we're fine. Everything's fine. We're fine. 4 goes to 9. And last but not least, again, don't write it again. We see 2. 2 goes to 10. Is that normal? No way. Lauren's shaking her head. No way. 2 goes to 6 and 10. You can't have a birthday on December 6th and January 10th. That's crazy. So this is not a function. Not a function. Okay? Now, do you have to write those bubbles out? No, you don't have to. Usually what I'll do is I'll go through, and if I see an x value listed twice going to 2 different y values, then the answer is no. Okay? So if I see 2 x values, no, can't do it. All right, try the next one. I've got -2, 5, -1, 3, 3, 7, 4, 5. Real quick, decide yes or no, function, not a function. And visually, I like doing the balloons for you guys. Domain range, X, Y. Take a second, decide yes or no. Function, not a function. All right, put your hand on your head if you think it's a function. Put your hand on your head. Now tap your head and rub your belly if you think it's a function. Tap your head. No, I'm kidding. All right, so we got a lot of people that think it's a function. Fantastic. Again, if I write this out, -2 goes to 5. -1 goes to 3. 3 goes to 7. And 4, don't write another 5. 4 goes to 5. It is okay that these two guys, -2 and 4, have the same birthday, January 5th. Totally fine. So this is a yes. It is a function. Okay? This is my domain. This is my range. Never write a domain value twice. Never write a range value twice. Do you guys have any questions about domain, range, functions? Any questions at all? All right, it's 2 o'clock. We're moving on then. Here we go. Second goal, find values of a function. Okay, you guys have done this before. This is nothing new. Okay, we've done this many, many times. All we're going to do is plug and chug. We're going to plug and chug. We're going to follow our dear Aunt Sally. Please excuse my dear Aunt Sally rules. Or maybe you don't have a dear Aunt Sally. Maybe you have a dear Aunt Susie. Follow those dear rules, your Susie rules, Sally rules. And let's dive into it. So the function that they gave us here is 2x squared plus 4x. Okay, so this is my function. The notation that you guys are going to see is f of -1. Well, normally it's f of x, so that number is my x value. They're saying, hey, x is -1. What do you get when you plug it in? So go ahead and plug it in, plug it in. We're going to go ahead and plug in x anywhere, plug in -1 anywhere we see x. I usually put parentheses. And inside parentheses, I'm going to plug in that -1. If you have multiple x's, you got to plug in -1 multiple times, like we did here. What do we do first? First thing we do. What do you guys got? Your exponents. Very good. So you got to take this -1 and square it. What's -1 times -1? +1. Very good. Now, if you want to start doing your multiplication, you can. So 4 times -1 is -4. And just for sake of notes, 2 times 1 is 2, minus 4, we should get -2. Okay. Same thing with f of 2. Do we need to see f of 2 done? Yes or no? What do you guys say? Can I get a thumb on where we're at? Do you need to see f of 2, or are you guys good? Thumbs up, move on. I don't want to waste your time. Then I'm going to move on to the next one. It says f of -x. If your input, this is my input, just like -1 was my input, -2 is my output. If my input is in terms of x, then my final answer, my output, is going to be in terms of x. Now, the nice thing is we've done this already. We've done this when we tested for symmetry, if you guys remember. Remember placing x with -x? It's the exact same thing. So we go through and we rewrite. But instead of x, I put parentheses, and in the parentheses, I'm throwing in a -x. And we simplify. A -x times a -x, or a -x squared, is positive. So that's 2x squared. And then 4 times -x is -4x. And that's it. Your answer is going to be in terms of x. That's your output. That's your dependent. Okay. I do want to hit up on this one because this is as hard as I would make it on a quiz or test. It is f of x plus 1. So again, I use my function up here. So f of x plus 1, I've got 2x squared plus 4x. So I put parentheses where the x would be, and then in the parentheses, I'm going to do x plus 1. X plus 1. All right. You guys say exponents. Well, what do we got to do with this guy? What do we have to do with x plus 1 quantity squared? Who's got it? Yeah, we got a FOIL. First, outers, inners, last. So again, very good. The idea is there's two terms here. If I take two things and I square, now I should have four things. That's your four-letter F word. You can say math class. We can't say the swear word, which you all know. And you can't say fire. Do not say fire in math class. Because then everybody thinks there's a fire and you're going to run out and pull the fire alarm. We don't want that. All right, so I'm going to go ahead and FOIL that thing. X times x, we know, is x squared. So we get x squared. X times 1 is 1x. Do it again. Now I have two of those, two x's. And then 1 times 1, so 1 times 1 is 1. So far, so good. Now, make sure you put the parentheses around that. Now, I've got to distribute to all three, and then all two terms. So now I've got 2x squared. 2 times 2x is 4x. 2 times 1 is 2. 4 times x is 4x. 4 times 1 is 4. Last but not least, combine all your like terms, right, in descending order so the power of x gets smaller and smaller. I got 2x squared. 4x and 4x is 8x. 2 and 4 is 6. So final answer, woo! Final answer, 2x squared plus 8x plus 6. All right, all right. Do you have any issues with that one? I'm looking at the chat. I don't see any chats. Nobody's chat snapping. All right, all right. Here we go. We move right along. No questions. Here we go. You don't need a fact. Somebody asked if we need to simplify this or like factor. Factor is actually opposite of simplifying. So just leave this one the way it is. So 2x squared plus 8x plus 6, like don't try to factor it. Leave it just like this. Okay, great question. All right, next. We just talked about finding values. Now we're going back a little bit to functions. Okay, so determine whether the equation is a function. So I want to hit this up twice. Every person can only have one birthday. Every X has only one Y. All right? Only one. Well, how do I tell that given an equation? Well, let's take a look. The first thing I always do is I try to get Y by itself. Usually our equations are Y equals or F of X equals. So if I have Y squared, I'm going to try to get that by itself. So I'm going to square root both sides. When you square root both sides, I get Y equals the square root of X. But don't forget what? What did I forget? Anytime you square root both sides, you must have plus or minus signs. Awesome. So don't forget the plus or minus. Now, when I take a look, I have to decide if this is a function or not. Okay? Now, think of a number that's nice and pretty that we can plug in and square root. Give me any of your favorite numbers that give you a nice square root. What's an X value that we can plug in? Anything you want. What's that? What number do you guys want to square root? Kayla, what'd you say? 49. Okay. Square root of 49. You can plug in anything you want, any x value. When I do that, I get y equals plus or minus 7. So when I plugged in 49, that went to 7 and negative 7. So that guy has a birthday on December 7th and January negative 7. Tori, can you do that? Is that normal?
No.
You can't do that. You can't have 2 birthdays. This is not a function. Okay. Now, the telltale sign right away, if you don't want to do all that work, totally fine. If you ever see a y squared, that means you're going to have 2 y's. Or if I see y equals plus or minus, like I see on example 9, y equals plus or minus a square root, then I know right away, not a function. That's the only time where you're going to see something that's not a function. If you have it y squared, or if you have y equals plus or minus, not a function. That's the 2 things that you got to look for. Okay. So for number 8, if you look at that one, y equals x squared minus 16. If I threw this in my calculator, it's going to graph it. And then I could plug in any x values. I could go second trace value and plug in any x values. If I plug in 0, I'm going to get 16 negative, right? One value. If I plug in like 4 squared is 16. 16 minus 16 is 0. And I could keep going and going, and I'm going to plug in any x value and only get one y value. Okay? So this is for sure a function. This is a yes. This is not a function. This is not a function. Okay? Any questions? Almost done, y'all. Almost done. Couple more things we got to talk about. Last thing, domain. Domain of a function. Remind me, is domain, what is domain? What are we talking about? X values. We're talking about x values. Very good. Okay. Now, when we plug in an x value, I should get something out, right? X's are my inputs. So I need to figure out what values can I plug in. More importantly, I got to figure out what values I can't plug in. Okay, so when we're talking about domain, we're trying to find x values that work, which means gives an output. We're trying to find x values that work that gives us an output. More importantly, we're trying to find really the values that don't work, because that's easier to do.
Your mic cut out. I couldn't hear what you were saying.
Okay. So let's say that again. So we want to find values that work, that gives an output. So domain are x values that work for our function. Now, that's pretty hard to come up with, because if you think about all of the numbers that work in something, think of every number you could think of. That's the real numbers. The set of real numbers are infinite, right? Positive and negative, whole numbers, integers, 0. So -1, -2, -3, 1, 2, 3, 4, 5. And then everything in between, fractions, decimals, square roots, anything like that is considered, okay? So really now what we have to do is we have to find what makes it undefined. So we have to find what value makes it undefined. So When you run into this, you're going to run into really two ideas today, okay? The first one, the first function is a fraction. At what point do you guys run into issues of undefined or error messages with your calculator? What can you not do in fractions? Do you guys remember? What can we not do with fractions? Trevor, Trey, Isabella, Logan, what can you not do? Jillian, what can't you do with fractions? When you're dividing numbers, what can you not divide by? Zero. We can't divide by zero. So that's something we need to know. If we don't know, now we know. Biggie Small says that. If I have any number and I divide by zero, that is undefined. Okay? Can't do it. It's the empty set, the null set. Can't do it. So, whatever's on your bottom, whatever's in your denominator, cannot be zero. Okay? Now, domain starts with the letter D. So does the denominator. Never set the numerator equal to zero. It's the denominator can't be zero. We can't divide by zero. So x plus 4 can't be zero, and we subtract this over. And we get x cannot be negative 4. Okay? Now for me, that's fine. Just listing that x cannot be negative 4 is your domain. You might see some fancy brackets. So D equals the set of all real numbers such that x cannot be negative 4 is how you read that. So D is domain equals, these are brackets for the set, fancy brackets. X bar just means all real numbers. So domain is the set of all real numbers except for negative 4. So you can think of any number you want and plug in to that function. I can plug in 0 here and here. I'll get something. I can plug in negative 3. I can plug in a decimal. I can plug in a fraction. I'll get a number back. But if I plug in negative 4 plus 4 is 0. And then whatever I get on top divided by 0 is undefined. That cannot be part of my equation. Can't be part of my domain. Okay? So my domain is all reals except for that number. All right? So I'm going to move on to 12. This one here, I'll zoom in a little bit. So now I have a square root. Okay? So if you have a calculator, get your calculator out and figure out what type of square roots can you do. Can you do square roots of positives and not have any issues? Can you do that? Let's see if I can put this to the camera here. I don't know if you can see this or not. I'm going to do a square root. So square root of, let's do 16. So square root of 16, can you see that, is 4. If I do the square root of 0, I get 0. But if I do the square root of any negative number, let's say negative 25, I get an error message, non-real answer. That's undefined in the real world, okay? I don't know if you could see that or not, but you can't do square roots in negative numbers, okay? So, maybe write that down. Do that in red so we can see it. The square root of a negative number is the null set, the empty set. Can't do it. It's actually imaginary. Something we haven't talked about in a while, but you talked about in Algebra 2. Okay? But it's not real. It's imaginary. So what do we do? Well, anything underneath that square root can't be negative. So that's a negative sign. Well, if it can't be negative, it can be positive and it can be 0. I just did the square root of 0, I got 0. I did the square root of 16, I got 4. Well, how do you say that? If it can't be negative, but it can be positive, it can be 0, How do you write that mathematically? That's the question. So if it can't be negative, it can be 0, it can be positive. What is that? Any idea how to write that mathematically? Can't be negative, but it can be positive and 0. So it can be equal to 0, and it can be yeah. I don't know who said that. Was that Kaylee again? That was Jenna. Nice job, Jenna. So I got greater than or equal to 0. Okay. So if it can't be negative, it can be positive. That's greater than 0 and equal to 0. Okay. So mathematically, we would just add the 4 over. And we get x is greater than or equal to 4. Okay. For me, that would be fine if you're listing the domain. The fancy way to write it is the domain is the set of all real numbers such that x is greater than or equal to 4. Okay. You could also write that using interval notation. That would be a bracket on 4 to infinity. Okay, so these are the two concepts that you got to get down. If you have a denominator, that can't be 0. If you have a square root, it can't be negative, so that's greater than or equal to 0. Okay, so I'll highlight those two ideas right there. Denominator. If you have a denominator, that can't be 0. If you have a square root, that can't be negative. That has to be greater than or equal to 0. Okay? So when I look at it, I got 2 more and I'm almost done, guys. If I look at 11, do you see any square roots? I got none. I see a square, but I don't see a square root. Do you see any fractions? Y'all are shaking your head no. No fractions. So then there's no restrictions. I can plug in any number I want. I can plug in 0. I can plug in negatives. I can plug in positives. I can plug in whatever. And I will get an output back. I'll get a number back. I will get nothing that says undefined. Okay, so my answer, infinite amount of answers. IMS, infinite many solutions. The infinity sign, all real numbers. You can do the fancy R. You got lots of ways you could answer that. Okay. My math lab will probably have all real numbers as a possibility. All right, so no fractions, no square roots, no restrictions. Last but not least, 13. Now we have a fraction, and in the denominator, we have x minus 3, right? Well, that's like these two ideas put together. So if I look underneath of a square root, we said underneath of a square root can't be negative. It can be positive or 0. Let me rewrite this. So x minus 3 is greater than or equal to 0. Okay? That's from this one, right? But it's also in the denominator, and the denominator says it can't be 0. So the denominator kind of overwrites this equal to sign. And we got to get rid of that. So it's really just x minus 3 is greater than 0. And we get rid of the equal to sign because it's in the denominator. If it's in the denominator, it can't be equal to 0. Okay? So put these two ideas together, and that's what you get on this one. Because the square root's in the denominator, we solve this, we add the 3 over, and we get x has got to be greater than 3. Okay? And I'm okay with you just leaving it like that. If you want to do the fancy brackets, you can. I think my math lab will have the fancy stuff. All you got to do is put in the set notation, the x is greater than 3 part. Ladies and gentlemen, do you have any questions with domain?